So let's talk about conservation of momentum. So currently we've been talking about impulse, which means we have something that's interacting with an external part of the system. So if the ball is the system, the table is the environment, so the table provides an impulse, okay? What happens if we have two balls that collide into each other, all right? So in this situation, we want to think about what's happening to the momentum and impulse. So we apply impulse momentum theorem. We know that our system has a total initial momentum, okay? Which would be the momentum of this plus the momentum of this. So this would be this mass times this velocity plus this mass times this velocity. If you want to get real nitpicky, one of these is negative, right? But we sort of hide that in the variables. When they collide, what's happening? What do we know about the force of interaction here? Yeah, I put that up too soon. But yes, it has equal, this is an action-reaction pair, right? The force of ball 2 on ball 1 should be the same as the force of ball 1 on ball 2. So if we have equal and opposite forces, how are the times of impact going to be different or the same? Yeah, if these two things are in contact, the time for this one and the time for this one should be the same, right? Because it's in contact with the other one. So that means you have the same force, but in the opposite direction and the same time. So what does that tell us about the impulse?
Should be the same.
Should be the same, equal and opposite, right? Just the sign is different because the force points in a different direction, which means we also have an equal and opposite change in momentum. Okay, and this is the basis for conservation of momentum, because that means that since the impulse is the same for both of them, the change in momentum has to be the same for both of them. Okay, so that brings us to momentum being conserved. And this is just our short, you don't have to memorize this, but this is why momentum conservation works, right? We have equal and opposite forces, same time, same momentum. Same impulse, which means same momentum, okay? So at any point in the collision, the momentum should be conserved. And that just means whenever you have two or more objects in a system, the total momentum of the system doesn't change. And here's an example of conservation of momentum. Yeah. But you can see some of the impact was lessened because they didn't run directly into each other. The squishy balls provided a longer time over which the force could be distributed, okay? This is still going, yeah.